then it almost looks like, imagine a world where 2 scores on either side of me are empty, and they all get bunched up at this point, or maybe my score and then 2 on one side, 1 on another, so there's sort of 4 in all. That would generate this pattern. So the fact that if there's a little bit of empty space around each lowest performer, just 1 or 2 points on each side, you would actually get this sort of 4-to-1 jump, because you're grouping a couple of points into one. So you can almost back out how sparse the data is near the threshold by the jump at this point. Does that make any sense to people? You guys getting where I'm at? If you were lumping together 4 points into one, you'd have 4 times as many students at that point, and you roughly have 4 times as many students. So in addition to my point, the winning point at 0, if you had like 2 on one side and 1 on the other, that would be 4 points I'm lumping into one. So that's not super dense, but it's in the middle. It isn't like they're separated by 10 points or something like that. It's like within a couple points of me, there's someone else who also ranked this school first, who also got a good score from my gender, from my district. And that seems kind of reasonable with like 50, 60 districts. Okay, so let's move on. So what do they find? And this is really the punchline of the paper. Very interesting. They don't find impact on school completion. So getting into a national school does not affect your likelihood of graduating from secondary school in Kenya. That's one result. The second one is there's no impact overall on test scores. Going to one of these fancy national schools with the aviation courses and Latin classes and whatever else people do in fancy schools doesn't affect your test scores on the exam that allows you to get into university. It's a very important exam at the end of secondary school. Okay, so remember, the people that don't get into these national schools are still good students. They typically go to the good provincial schools, which are still very elite. I mean, we're still talking about the top 1 or 2% of the distribution in terms of test scores. But going from like the super elite school to the pretty elite school doesn't affect your test scores. And in fact, their estimated effects are very precisely estimated. The standard errors are small. So they can rule out, if they have a 95%, if you have a 95% confidence interval, the 95% confidence interval excludes pretty small effects of around 0.1 of a standard deviation unit, which is considered not too big. So they can rule out effects of that size. So this is a pretty interesting result. A ton of money is being spent on these schools. They're very expensive. People like, fight, kill, steal, whatever, to try to get into these elite schools. But if you don't get in there, but you get into one notch down, you get the same score 4 years later on your secondary school exam, which is what gets you into university. That's a very interesting finding. So this is what the data looks like. Again, we can do everything in pictures here, which is cool. This is what they call progression through secondary school. This is the probability of graduating in 4 years. So this is the odds that 4 years later you've graduated. You'll see a couple patterns here. The first pattern is this relationship is upward sloping slightly. In other words, the really, really good students basically are all graduating in 4 years, almost all. You can see there's a whole bunch of data points there at 1. For some of those really top scores, every single student graduated in 4 years. So those are really good students. They're not dropping out, et cetera. But even the somewhat weaker students still have an 80 or 90% probability of graduating. So these are all good students that are almost certainly going to graduate no matter what. But you don't see any really noticeable jump at the threshold. It's not like that other figure I showed you with that huge jump. They're pretty much all graduating around that range. Can anybody notice any other things with this plot? Yeah. It's pretty interesting, right? And you do kind of see it jitter around, and then way over to the right. Again, remember we saw this last time, like way all the way on the right, you see these folks there, but we probably think these are people that study abroad or go to like the fancy international schools. Those are like the top students in Kenya that may just have a different set of like really super, super elite opportunities open to them. Maybe some of the variance you see even earlier is related to that. But we don't know for sure, but it is interesting to see that. The other, what would be, so that's one explanation. Some of these guys are dropping. What would be another explanation? Exactly, and that is true. So the very, very right tail has fewer people per point. So you probably would see some more noise just because there's fewer people in there. So it's what would be called sampling variation, which we talked about in other contexts in this course. Hold on. So maybe sampling variation is part of the story. In other words, with a small sample, you just get more noise because there's few observations. So one outlier can push the average around, or 2 outliers. Yeah. That was the one I just showed you again here, this one here. So here you see a big jump in admission right at 0. But being much more likely to get admitted doesn't affect the likelihood of completing here. So the one from last time is really just the same one I just showed you earlier today. That's the one I was referring to. There's a big jump in graduating from a national school right at 0. But it doesn't seem to affect the probability you graduate from any secondary school. Okay, now an even more interesting one is the test score result. This is the test score result. Same sort of pattern here, very clearly upward sloping relationship. I mean, the folks who are stronger students remain stronger students than the ones who are weaker students. So that comes through really clearly. But what's surprising, maybe, is that again, there's really nothing at the discontinuity. There's just no effect. Being in the national school doesn't seem to affect things very much. Can anybody observe any other interesting patterns? Actually, looking at it this way, I think you can really almost feel the sampling variation, right? Like you have a lot of observations here, closer to the middle of the distribution, and it kind of just spreads out as, if you only have 30 people per cell all the way on the right, and you have 300 per cell over there, you're just going to have more noise going to the right. So this is actually a neat figure to illustrate that. Any other observations or thoughts on this plot? Is this what you would have expected? Did you think these fancy schools were going to improve test scores? Yeah. Yeah. Over here, you're saying. It almost looks like here you get something more like that. Yeah, that is true. I mean, the only thing is you do get those observations up there too, which might be the sampling variation. So I'm not sure exactly what it would look like, but I can see what you're saying. There's a lot of math suggesting a kind of flattening out there. Some of that could be that the KCSE, the secondary school exam, you might end up getting close to perfect scores on that exam at some point. So the issue would be if all these folks have some chance of getting close to a perfect score, then their academic ability may not be reflected on the exam. That's one possibility. Another possibility is something that looks a little bit more like mean reversion, which is like maybe these guys just got a little bit lucky to get this kind of perfect score early on, and over time they're really not that different from the people over here. So the scores kind of look similar. So in general, with mean reversion, you'd expect some kind of flattening out as well. Yeah. You think, sorry, say again, the omitted variable bias would be related how to the score? Yeah, almost certainly. And I think this may be the sampling variation issue, that it really feels like heteroscedastic. Like at different points here, you have fewer observations, so you've got this like spreading out of score. I think looking at it here, it looks like it almost has to be, right? You just see the spreading out of scores with less data on the right tail of the distribution. Yeah, I think it has to be what you said. Okay, so what does this look like in a regression? And actually, they present a few regressions here, and this is a really nice table because it captures a lot of the things we've been talking about. In the first column, which I've blocked out here, what they do is they use all the data, 200,000 kids that year taking the exam, and they say if you are on one side of that threshold, the zero threshold, graduating from a national school, or the other, how much better do you score on the secondary school exam? And not surprisingly, we know that the folks in the national schools had the best test scores going in, and on average, they scored better. They score about 0.3 of a standard deviation unit better. And that's even controlling for some stuff. So yes, people in national schools score better. So if you just go out into the world and you were to meet someone from a national school, they're going to tend to be really strong academically. There's no doubt about it. Once you narrow the analysis in column 2 to this window of about 30 points above and below the threshold, though, it's a lot tighter. Now we're only looking at the good students. Once you narrow the threshold, there's not really much evidence at all that these folks are better students. Now it's 0.05 of a standard deviation unit. It's really small. And some of that isn't that surprising either, because they got in precisely because they were slightly better students. So you'd expect there to be a positive effect. What's more interesting is what they call the reduced form here in column 3, which is now let's ignore actually graduating from national school. Let's just compare people on both sides of that cutoff. So this is the test score cutoff greater than or equal to 0. That's an indicator variable, a dummy variable for that. That's what this admitted to a national school is. An indicator for that your test being greater than or equal to 0. And this is basically the discontinuity that we saw, the lack of a discontinuity. Column 3 is the equivalent of the figure that I just showed you. That's what column 3 is, saying that there's really no jump at the threshold. The secondary school KCSE test score is no higher for the folks just to the right of the threshold. Okay, now there's a fourth column, the IV estimation. We're going to get into IV starting in lecture 16 and 17, but this happens to be like a perfect setting for getting the intuition of IV, so let me explain it to you guys. The idea of IV, instrumental variables, is to say, what we're interested in here is, what's the effect of graduating from a national school? We want to know that. That's sort of the bottom line of the paper. But the people who get into the national school and the people who don't differ. People get in have better test scores, so they're not really the best comparison group. But we can take advantage of the discontinuity and compare people right near the discontinuity and say, for people right near the discontinuity, we know if you're just to the right of the discontinuity, you're much more likely to get into a national school by 50%. Remember that 50 percentage point effect, right? That was the first figure that I showed you. There was this 0.5 point increase in the likelihood of being admitted to a national school, or sorry, graduating from a national school if your test score was just to the right. So instrumental variables makes a different assumption. Every method has an assumption. The instrumental variable assumption is the only effect of being to the right of the threshold works through being in a national school. Let me say that again. If you're just to the right of the threshold, if I think being just to the right of the threshold is having some effect on my secondary school test score, it can only operate through the fact that being just to the right of the threshold increased the likelihood that I went to a national school. That's the only thing that's changing at that threshold. Nothing else should be changing dramatically if I go from -1 to 0 on that score. It's all being operated through this huge jump in getting admitted to a national school. That's the IV assumption. That's what's called the exclusion restriction. We're going to come back to this in a lot of detail starting on Thursday. So let me ask you guys just to think about it. If being at 0 rather than -1 increases your odds of graduating from a national school by 0.5, and being just to the right of the threshold increases your test score by 0.008, now that's not significant, but let's take that coefficient seriously, then what does this method tell us about the impact of being in a national school, graduating from a national school, on your test score? You can actually, it's some algebraic operation between just two numbers, 0.008 and 0.5. How should we use those two numbers to come up with the effect of graduating from a secondary school, an elite secondary school? Those of you who have studied IB are at an unfair advantage, but take advantage of it and explain the intuition. How many people have studied IB in a econometrics class? Oh, okay, a little bit. Everybody's like, oh, don't call me. Okay, I saw your hands though. Can anybody think of the intuition? Okay, let me explain it a little more and then maybe it'll come out. If I'm right at the threshold, I either graduate from the national school, we'll call it NS, or not. And being just to the right of the threshold makes it 0.5 more likely that I will graduate from a national school. Okay. So let's make the assumption that the whole effect of being just to the right of the threshold operates through graduating from a national school. So this 0.008 effect of being to the right of the threshold is, yeah, do you have a question? Do you want me to work through the algebra first? Or? Yeah. The national schools here are all secondary schools. Now people enter secondary school a little later in Kenya than here. So they're kind of in there, they're like 16 or something. So it's like a little earlier than we go to college, but a little later than we go to high school. Okay, the 0.008 effect is the average effect among those who graduate from a national school, right? Weighted in some way that we'll talk about, plus the average effect among those who did not go to a national school times some weighting. Okay? The easiest way to think about the instrumental variable assumption is that we're assuming that the average gain, if you didn't go to a national school, is 0. The whole effect works through being in a national school, right? We know that, or that's the assumption. So this is 0. Sorry. So we're left with the first term. And the weighting we should apply is the average change in going to a national school, if I'm just to the right of the threshold, is 0.5. That's what the weighting is here. So you can actually get the average effect from graduating from a national school by dividing 0.08 by 0.5. This is the intuition. So think of this just as the whole effect is concentrated because when you get just to the right of the threshold, that makes you much more likely to go to a national school. That's the 0.5 effect. That's where it's all operating through. So the average of 0 among those who didn't go to the national school, plus the effect for those that go to a national school is 0.08. So this is exactly the formula for the simplest IV estimator. The simplest IV estimator here is just 0.008 divided by 0.5, which you'll see is almost exactly 0.015, other than rounding. That's where the IV estimate comes from. This top one here is called the reduced form. That's what they call it in column 3. This bottom one, which is the effect on graduating from a national school, is called the first stage. Okay, so I'm just anticipating what we're going to start doing on Thursday, but this is a very simple application of the idea. If all the effect goes through graduating from a national school, just by algebra, you get 0.015. Let me pause for a second. Is this how you were taught IB before? No. This is actually much simpler, as we'll go through, but we'll generalize this to the exact formulas you studied in econometrics next time. Yeah?
Given the point on average effect of going to the national school, right?
Mm-hmm.
Is that interpretation more likely? Is that saying that you're going to graduate if you're more likely to graduate?
Exactly.
Or you're more likely to graduate from that national school?
Yeah, you're 50%. The previous table in the first figure said you're 50 percentage points. You're 0.5 more likely to graduate from a national school if you were just to the right of the threshold.
But not everyone just the right threshold goes to that.
Exactly. Exactly. If everybody just to the right of the threshold went to the national school and we had what we call the sharp discontinuity, so at the threshold, it went from 0% to 100%, then all we would need to do is look at the reduced form. Because that would perfectly tell us the difference between going to a national school and not going to a national school. But because not everybody goes to a national school, we have to reweight the data by the 0.5. And you can see, if this wasn't 0.5, but this was 0.2, there was a smaller jump, we'd have to reweight the estimate even more. We'd be dividing through by 0.2 because we'd be saying whatever effect we find is all concentrated among those 20% of people that go to the national school because they're just to the right of the threshold. So the strength of the first stage is going to affect the IB estimate. Okay, that was a very exciting 8 minutes for me. I'm glad I threw it out there. Most people are puzzled. We're going to go through this in a lot more detail. But this, when we come back, once we've done IB fully, when we come back to this, this is going to look really trivial and really easy. But the good thing about this is it's sort of a very easy case for explaining it once you get it. So let's put these lecture slides in a box, think of them often, and then we'll move on. Okay, so this is the IB estimate. We're not fully up to speed on IB, we will be soon, but what we can get out of this is the 95% confidence interval. And the 95% confidence interval is going to be driven by this standard error. So the 95% confidence interval is going to be the point estimate plus or minus roughly 2 times that standard error of 0.053. And that's what's going to give us this confidence interval from about minus 0.1 to about plus 0.1 standard deviation units. That's the confidence interval. In other words, we're confident that the effect of being a national school is right around 0. There's just no big effect. It isn't like there's some realistic possibility of having a huge effect on test scores. It's basically like a dead on 0, right around 0. Okay, let me pause and see if there's any questions, either on the IB or on other stuff. So there's one exception to the 0 test score results. So to take this in the secondary school exam, you take multiple subjects. And across all the subjects, there's 0 effects, except for one of the 5 subjects or 6 subjects, I forget how many. Swahili. For Swahili, there's actually a positive point estimate. Swahili is one of the 2 official languages of Kenya. The other is English. Swahili, though, is used much more in sort of informal conversation among people, and English is used in more formal settings. Why might there be a big gain in Swahili here, in these national schools? Just based on the description I've already given you of these schools. Yeah. Okay. So maybe elaborate on that a little bit more. Yeah, so that won't be enough because people in national schools and provincial schools still speak to their friends. So there has to be some differential use. Why would there be differential use of Swahili in a national school versus a provincial school? Okay, so they find some evidence that in the national schools, they give more assignments in Swahili. So that's one of the 2 explanations. The second one is very close to what was just suggested, but a little different. Yeah. Yeah, so that's part of it. Part of it is the lessons in Swahili, but there's another kind of tweak on the explanation before. Yeah. So that's part of it, and all you guys are touching on one thing. There's one thing Lucas and BT said that was just a little bit different. I think all of that is sort of part of the same thing about lessons, but there's one other thing. What is unique about a national school? Exactly. So in the provincial schools, people are from the same region and very often will speak colloquially in what's called the local vernacular. So the local language of the dominant ethnic group in that province or that region. But in the national schools, you literally have people from every district. They're structured that way. They have quotas for people from all over the country. So in addition to the lessons, and they find some evidence there are more lessons, people just have a much more multi-ethnic group of friends. And they're speaking to them more in Swahili. So that's actually a pretty substantial effect. And this is a very interesting finding in the sense that one of the goals, if you read the history of the national schools and what the early post-independence government wanted to do with the national schools, was build a nation and build a common Kenyan identity. So mixing people together does that, but also speaking Swahili, an African national language, also accomplishes that. You have a comment? They take very similar number of classes. What they did some interesting surveys where they tried to look at the amount of time spent on different subjects. And like a lot of you were suggesting, in the national schools, they just spend more time on Swahili. So it's emphasized more. But I think a big part of it is probably the informal interaction. So you can imagine if you're in a very multi-ethnic environment, everybody speaks one language, you're going to speak that rather than your provincial or your regional language. So in that sense, it has a nation-building focus. So these are the 2 explanations, just as you guys were saying. The teaching time, but then the kind of multi-ethnic populations. These are very diverse schools. People from all over the country are mixed together, and that has some effect. So it's time for our first clicker question. And I want us to just reflect on this study. We're going to wrap up this study in the last half hour, get on to the last of the education studies. And so the question is, we've gone through last lecture and this time, Lucas and BT, what the limitations are, what the strengths are. Here I've listed out 4 potential limitations, and I want you guys to weigh in on which of these you see as the most important limitations, or if none of them you think of as important, maybe you have another idea of what you see as limitations. So one is maybe the treatment effects are very local, only among high-achieving students. Maybe there are too few observations. Maybe there's manipulation of test scores. Maybe the secondary school exam is too narrow to be of much interest. Maybe none of the above. Maybe you have another idea of the best, most important limitation. But this is just, and feel free to discuss with your neighbor for a minute about this.